At the first glance, this shape looks like a random splash of geometry. It's irregular, it's curvy, it doesn't fit nearly into any of the shapes we used to calculate. You might think, there is no way to find the exact area of something like that. It looks impossible, right? But wait, it's actually simple to solve. With the right approach, its seemingly random shape breaks into the clean, straightforward steps. In fact, by the end of the video, you will see how it looks impossible is actually a very possible and easy to solve problem that requires nothing more than school knowledge of geometry. An artist drew a crescent shape on paper using two arcs. One arc is form a circle centered at 0, 0 and passing through point 0, 1. And the other is form a circle centered at 1, 0, also passing through point 0, 1. The ink spreads overnight, so each point in the crescent becomes a circle with a radius of 0.5. Calculate the area of the ink covered shape. Let's start with recreating diagram. So let's make a simple Cartesian coordinate plane. So let's draw a rectangle, two axes, x and y. Let's carefully move one of the axes. Let's make it more like a circle, squares. Now let's label the coordinates. So the top point of interception would be 0, 1. And top right point is 1, 0. So let's label the axis. Also let's label the origin. So we have it as 0, 0. Now let's start drawing circles. So the first circles, as we know, has a center at 0, 0 at origin, and it has radius of 1 unit. So we place it here. Let's just carefully align everything. So we have our first circle, and the second circle, we know that it has a center at 1, 0, but we don't know the radius, but we know that it also passes through the point 0, 1. So let's try to feed the circle. So we have to adjust the radius. This is a very rough sketch, just to give you the idea how to construct this idea. Unfortunately, this tool does not allow me to very carefully and precisely position all the elements. So this is just a rough sketch to give the idea how to do this. So here is the next circle, and this is shaded blue area is the area of our crescent that we will calculate, and let's call it area 1. Now let's take a look at the shapes that we have. So let's find the radius of the larger circle. So we connect points 1, 0 and 0, 1. So both legs equal 1, so the radius is square root of 2. This distance is also equals to square root of 2. And now we can connect point 1, 0 with the bottom point. That's also a radius of the circle, so it's also square root of 2. And now we have two triangles. Both of them are isosceles triangles. They have legs equals to 1, and this is, let's mark this green area that we want to calculate to find the area of the crescent. So we need to calculate this green area. We need to subtract it. We need to find this green area. In order to do that, we will calculate the area of two triangles and subtract that area of two triangles from the area of the quarter of the circle that we have. Now the harder part. We need to calculate the area of the splash. So since each point of the crescent generates basically a circle, that means that the furthest point from the contour of the crescent will be equally distance across all the crescent. So let's try to figure out how to calculate that. So first we have our inner boundary. This is our circle, our blue circle with a center of 0, 0. And we create another circle with a radius a little bit larger. We call it plus r, in the same center. So we align centers of that circle to match the our first blue circle, and then what we need to do, we need to calculate half of the area between those two circles. So let's call that area 1. Let's call it area 1. So this is this blue area between two circles. So this is our first area that we will need to calculate as an area of the splash. So we have our first area that we will calculate a little bit later. Now let's figure out how to do the inner part, how to calculate the inner part of the splashed area. So we do the same thing. So the outside boundary is defined by our circle. Let's make a green circle with a center at 1, 0, and as we discussed before, it has the radius of square root of 2. Now from that radius square root of 2, we will subtract that r. Let's again connect the vertex at 1, 0 with the coordinates with the vertices at 0, 1, and let's call it 0, negative 1. This is the boundaries of our splash, and we will need to calculate this green area between two circles. Let's call this area 2. Now the last part, we have to deal with edges. So as you may notice, as you think about it, so the furthest points on the crescent, those edges also generate the splash with radius r, so that means we can cover it with a circle at the center of 0, 1, and the same circle with the radius r at the bottom at the point negative 1, 0. The most important thing here, at the end, we have to account for the overlap of the areas here to make sure that we use those circles to calculate only the area that we did not cover. Let's call those areas of the circles area 3. Okay, now once we have our strategy, let's move to the solution of the problem. So I recreated the image just to make it easier to work. This is more accurate image. So let's label all the radius of the splashes that we will need to use. Here is I broke down the shape into smaller pieces, into parts, just to make it easier to work and calculate each area individually. So let's label our areas that we discussed before. So this is area 1, this is area 2, and area 3. And I missed one more area of the crescent itself. This is shaded blue area. Let's call it area 4. And let's start with calculating the area 4, the first, so area of the crescent itself. Let's connect our edges exactly at the point 1, 0. those are radius of the inner circle. Let's draw the x-axis that we had, which is the radius of the outer circle. So as we discussed before, this angle is 90 degrees because we have a quarter of the circle, and because two legs are in the triangles are equal to each other, so each angle is 45 degrees, so the combined angle is 90 degrees. And this is our origin, 0, 0. So now, so those are legs 1, 1, and as we discussed, the radius is square root of 2. So now we have to calculate the area, as we discussed before, area of the crescent. So let's start with finding the area of each of the triangles. So the formula for the area of the triangle is 1/2 times leg 1 times leg 2, which gives us 1/2. So that means that the area of two triangles would be equal to 2 times that area of one triangle, which is just 1. So area of two triangles is 1. As you should know by now, area of the circle is pi r squared. So that means that if we want to find the quarter of the circle, we have to divide it by 4. So it's equal to pi r squared divided by 4. And since in our case the radius of the circle is square root of 2, it's equal to pi square root of 2 squared over 4. So now we also need to find the area of the half of the circle with the radius 1. So area 4 is equal to 1/2 pi 1 squared. And this is the area of this blue semicircle. So this blue area of semicircle, and from that area we need to subtract the inner part. Let's color it with pink, let's say, or purple. So we need to subtract this area. And how we calculate this area? So as we discussed before, the idea is that we have quarter of the circle, and we need to subtract from our half of the circle the following area: pi square root of 2 squared over 4, and we need to subtract the area of our two triangles. So again, this is the area of quarter of the circle, and we're subtracting two triangles to get this purple area. So if we combine like terms and simplify everything, we'll get pi over 2 minus 2 pi minus 4, everything over 4. And if we simplify everything here, we'll just get pi over 2 minus pi over 2 plus 1, which is equals to 1. So area 4 is equal to 1. Now let's move on to calculate the next area. This is area 1, which is the outer left side of the splash. And this area is easy to calculate. So as you remember, the radius of the inner circle is r, which is 1, and the area of the radius of the larger circle will be r plus r small, so 1 plus r. So that means the area between those two circles, we need to calculate areas of two circles divided by 2 and subtract the results. So let's do that. So area 1 equals pi 1 plus r squared over 2 minus pi 1 squared over 2. Now if we combine like terms, simplify it, we'll get pi times 1 minus plus r minus pi, everything over 2. So we'll keep it for now as is, area 1. Okay, now let's calculate second area. So the radius of the outer circle is r square root of 2. That means that if we subtract r small, we'll get square root of 2 minus 2. This is the radius of our inner circle. That means we can write down area 2 as pi square root of 2 squared minus pi square root of 2 minus r squared, everything over 4. So this is our area 2. And the last thing we need to calculate is area of two segments. So the inner angle is 45 degrees, the outside angle is 90 degrees. So we have a segment of 135 degrees. Since we have two of such segments, we can combine them and we'll get 270 degree or 3/4 of a circle. So we can write down area of those two segments combined as 3/4 of a circle with a radius r. Okay, now we have all the areas, so we can calculate the total area of the total shaded area of the splash. So let's start with 1 plus pi 1 plus r minus pi over 2 plus 2 pi minus pi square root of 2 minus r squared, everything over 4, and plus 3/4 pi squared. So now the only thing we need to combine like terms, simplify that a little bit, and if we do that, we'll get the following. 1 plus pi r plus pi r squared over 2 plus pi square root of 2r over 2 plus minus pi over 4 r squared and plus 3/4 pi r squared. And now we have to combine like terms here, and we will get 1 plus 1 plus square root of 2 over 2 pi r plus pi r squared. So if r equals 0.5, we can calculate the value of this expression. So let's do that. So it's going to be 1 plus 1 plus square root of 2 over 2 times pi times 1/2 plus pi over 4. Now we can use a calculator to estimate the result. So if you do that, that would be approximately 4.47 units squared. So this is the area of the splash. And as you can see, this problem is not that hard and does not require any specific skills besides the basic school knowledge of geometry and basic math. Thank you for watching. If you found this video valuable, please consider liking, sharing it, and subscribing. If you want to support us in creating even more videos like this, check out our Patreon page. Even a bit of support helps us continue to bring in you the best we can. Thank you again, and we're looking forward to seeing you in the next one.